All right, welcome back to Monads Exercises. Let's do this. All right, so let's take the exercises in turn. 1. The lazy monad. I'm actually going to implement lazy as a class. So class lazy of type, and I'm going to make this covariant plus a, which takes a value which is by name, this is very important, of type A. The by name prevents the value from being evaluated when the lazy object is being constructed. All right, so we have the class and we have a singleton object, which is a companion object lazy, and we're going to implement unit or apply of type parameter A, and this receives a value which again is a by name call of type A, and this constructs a lazy A. And this will just return a new lazy with the value. So notice how we already implemented unit as an apply factory method. All right, so all we're left to do is define a flat map. So flat map with type parameter B, and this receives a function from A to lazy B, and this will return a lazy B. And guess what the implementation here is going to be? Well, it's just f applied to the value, because it already constructs a lazy instance. So that's all there is to the lazy monad. That's just it, with a few lines of code. So let's see it in practice. If I create a lazy instance by calling lazy, the companion object, apply method, which is our monad unit, then if I print something to the console, let's say, today I don't feel like doing anything, because we like the song, and just return a value of say 42, then I should not see this lyric printed to the console, because this is a lazily evaluated expression. So if I right click and run this, ta-da, I don't see the lyric. But if I try to use the value, say print line lazy instance dot, and let's create a little method here, def use, which returns type A, and it's the value. And if we use the value here, or use, just call the method, then I should see both the lyric and the value of 42 printed out. All right, so we see a little bit of Bruno Mars and our little value 42 here. All right, so let's kill this and let's test our little flat map. So if I create a flat mapped instance, which is lazy instance.flatMap, and for the x executed inside, let's just construct a lazy with say 10 times x. All right, then I should see nothing printed to the console. So let's try it out. So let's run this. And unfortunately, I see the lyric here, which means that this expression was executed, even though I'm only flat mapping lazy monads. So this is a little bit wrong. Now, why does that happen? Well, it happens because if I do flat map on a lazy instance, flat mapping on a lazy instance applies f to the value. Now, value, because it's a by name parameter, applying f to it will evaluate the value eagerly. So that's why I'm seeing the today I don't feel like anything, the print line statement in the lazy instance flat map call here. All right, so the way that we could solve this is to change the function type to receive the parameter by name as well. So that will delay the evaluation of value inside f, because f receives the parameter by name. So if I right click and run this again, then I should not see the lyric in the console. All right. Cool. Now, there's another thing that I wanted to test, which is, let's copy this around. Let's call this flatmap instance 2. And do the following test. Say flatmap instance.use, which will force the evaluation of the flatmap instance, which in turn will force the evaluation of the lazy instance, the original one. And also write flatmap instance2.use, which will force the evaluation of this lazy monad, which in turn will force the evaluation of lazy instance. So let's see how many times we see the lyric printed out to the console. And unfortunately, we have the lyric printed out twice, which means that this expression is evaluated twice. I don't like that. When we operate with normal lazy values, we aren't evaluating them all the time they're used. We just evaluate them once at the first use, and then we use the already evaluated value. So let's change our little lazy implementation to evaluate the value once. And the way that we do that is, you've seen this by now, with a call by need. Okay, so we'll just use a private lazy val internal value, which is value, as in the class parameter, and inside we'll just use internal value whenever we want to process this. So if I right click and run this again, I shouldn't be seeing the lyric twice, but only once. Alright, that's because after lazy instance is evaluated at the first use of flatmap instance, then the same value is reused in the later call to use for flatmap instance 2. Alright, so this now behaves like a true lazy value, but as a monad. Now let's really prove real quick the monad laws. So left identity says that unit flatmap f is f of applied to value. Well, unit is lazy with a value, flatmap f equals, and take a look at the flatmap implementation. Well, it's f of the same value by the same definition. Right identity says that if I have a lazy value, flatmap unit, then that should give me the same lazy value. Well, lazy with some value, flatmap x lazy x, well, it just applies the function to the internal value, which is lazy v by definition. All right, so left identity and right identity are super easy. Now with the flat maps, we have the associativity law, which says that if I have a monad instance lazy with some value, flatmap f, flatmap g, well, this guy applies f to the internal value, which is fv flatmap g. And the right-hand side of the equality, remember, this says that if I have a monad instance, then if I do flatmap f and then flatmap g, then that is the same instance flatmap. And then for the value inside, it's f applied to that flatmap g. Well, lazy v flatmap f is f applied to v flatmap g. All right, and the right-hand side of the equality is lazy v flatmap, and for the value inside, I do fx flatmap g. Well, it's this guy applied to the value inside, so it's, of course, fv flatmap g. So super easy. These two are identical. So the associativity law is also maintained for our cute lazy monad. So if you've correctly written this lazy monad by yourself, congratulations. All right, now exercise number 2, which is map and flatten in terms of flatmap. So again, what the exercise said, if I have a monad T, which had our little flat map already implemented, then we want to implement map and flatten in terms of flat map. All right. So given a theoretical monad T, think of it as a list in your head. And if I have the flat map already implemented, then how would you implement map? Well, map is implemented in terms of flat map by calling flat map, where for the value or values inside, I could simply call unit, which creates another monad, and inside I just put in f applied to x. All right. So f changes from T to B inside a unit which constructs a monad of type B. So the end result is a monad B. All right. So that was map in terms of flat map. Now, how do you do flatten? Well, you call flat map on the monad, which, remember, this is a monad of monads. All right. And for every element inside, which is of type monad T, it's not a plain element, it's a monad itself, then you just return itself. Think about it. Let's prove this with an example with lists. So if I have list 1, 2, 3, and I knew an implementation of flat map, how would I implement map with doubling the elements? Well, I call list 1, 2, 3 flat map, and I would call unit, where for every x I would construct a list. So this is the unit function for list of this function applied to each element. So x times 2. All right. So this is map. Now flattening, let's say we have list, and inside we have two more lists, list 1, 2, and list 3, 4. And flattening that would be the same thing, the same list, dot flat map, where for every sublist inside, I just return itself. Think about this. So flat mapping with a function just yields in concatenating all the applications of this function on every member of this list. So basically, I'm concatenating this guy and this guy. So it's list 1, 2, 3, 4. All right. You can apply the same technique on all the other monads, on options, on try, on even on our own attempt and our own lazy monad. They work the same way. So these are prototypical implementations of map and flatten in terms of flat map. So we basically proved that the definition of unit plus flat map and unit plus map plus flatten are exactly equivalent. Alright, so you've learned a really important concept in functional programming. Monads are really difficult to understand, but now you've mastered it. I'm Daniel, and I'll see you in the next video.